we are continuing on with 2-3, dealing with this concept called slope. And what we're going to do is we're going to use number 13 in my first period class, which is awesome. They're always bright and cheery, aren't you guys? Totally. All right. Their silence. They're really not dead, everybody. They really are alive. Some people are smiling. Some people are angry. Some people just want me to be quiet. But we're not going to be quiet, Nick, are we? He's shaking his head. Now, yesterday we talked about how I wanted you to find slope. So if I said I want you to find the slope of FG, of that line, all right? What's the formula for slope? How did I tell you guys to do it, Austin?
Y1 on the Y2 over Y1.
All right, we have Y2 minus Y1
over X2 minus X1.
All right. Now, when I asked you to do this, in your journal and on your paper, there was a specific way I wanted you guys to do it. You didn't remember the specific way that we did yesterday that requires parentheses? How do we write that? Go ahead. Zion, tell me. What am I going to do? All right, so we put parentheses minus parentheses. Now, Kyle, I know you weren't here yesterday. I didn't mean to call you out like that. But the reason why we wanted to put parentheses is I want you guys to label Y2, Y1, X2, X1. Now, Caitlin, in your journal or whatever, you can put this as an example problem in your journal as far as how to go over things. Now, what I want you to do, our point F is at 0, -3. Our point G is at 4, -2. We're just doing a quick little review here. All right? So if you weren't here yesterday, you could put this down in your journal if you wanted to. Before I wanted you to solve the problem, Michael, I wanted you to do what with these ordered pairs? I wanted you to label them. That's right, label them. So we're going to call this X1. We're going to call this Y1. We're going to call this X2. We're going to call this Y2. Now, the reason we want to label is so that when we actually solve for the slope, I know we're going to graph it. We'll see the slope easier, okay? But if you didn't have a graph and you didn't want to graph it, we want to label things correctly. So, Bree, what's my Y2? You look up there. Look at where I find my Y2. -2, I agree. All right? Leon, what is my Y1 value? -3 is correct. All right? Sandy, what's my X2 value? That's correct. 4. Excellent. And Shayla, what's my X1? She said 0. I know you can't hear her way over there, sports fans, but she said 0. All right, now, the reason we're putting parentheses, Nick, is because I'm going to put a couple of arrows, and you're going to tell me why I'm putting a couple of arrows like that. Lets me know something big time's happening in the problem.
You got to make that a positive.
That's right. We're going to make that a positive. So we're going to have a -2 plus a 3 instead of a negative and a negative. That's a positive right there, so that becomes a plus. And then here we just have 4 minus 0. And when you finish the problem, you would get a slope of 1 over 4. So automatically, you know on your paper, you should see a slope of 1 over 4 for line FG. What we're going to do now is we're going to plot these points and see if we actually solved it correctly, algebraically. So F is at 0, -3. G is at 4, -2, right here. And so we should see a slope of what? 1 over 4. Let's see here. Does it go up 1 unit and over 4 units? It does. So we did that correctly. All right. So after you do that, also, we're going to go down 1 over 4. Put a point right here. Remember, there's 2 ways you guys can plot. You can go up 1, rise, and then run 4 units over, or you could go down 1, which would be -1, and over 4 units to the left, which would be -4, and the negative divided by negative is still a positive. So right now, you have a line. Make sure it's nice and straight. So on your paper, you should have a line right there that has a slope of 1/4. And so you have that part shaded to show that that goes up 1 over 4. Now, the next part says we need to create a line that contains point B and is parallel to line FG. So if B is at a what? A -4, +2 right here. what do we know about parallel lines? Same slope. So parallel lines always have the same slope. So we have to apply the exact same slope. Up 1 over 4. And up 1 and over 4. And now you've actually met both conditions. Not just one condition. You've met both conditions. You have, try to get those through there. There we go. Now you have a couple of parallel lines on your paper. All right? And both of them have a what? Have a slope of 1 over 4. You can do that by making these little right triangles. All right? And you might have heard a yawn, but you really didn't. All right? That wasn't me yawning. That was one of my students. All right? It is only 7:45 in the morning on a Friday, and they're really thinking about the weekend right now. All right? So before we fall asleep and wake up Saturday morning, let's review 14, because 14 is a heck of a lot different. We're not going to solve for the slope, Leon, this time. Mathematically, we're just going to plot stuff. You okay with that? Yeah, he's okay with that. Good. All right, so this time, the problem is what? We're dealing with this thing called perpendicular. All right? Now, I am not going to write the word perpendicular. What am I going to do instead? Because I don't like having to spell perpendicular. And upside down T, that's right. So right now, I need you guys to understand, anytime you see me write this, that's a horrible upside down T, right? This symbol right here means perpendicular. From your notes yesterday, for the people who weren't here, how do we find a perpendicular slope? What do we call it? A what? Opposite reciprocal, but there's another math way of saying it. We don't call it the opposite reciprocal, we call it the negative reciprocal, right? So the negative reciprocal will create a perpendicular slope. So, Austin, in your journal, you probably have some examples. So, if I said, let's say 2 over 3 was the slope, what would the perpendicular slope be? Negative 3 over 2. All right, Kate. Sorry, we'll say C over there. If I said 4 over 3, what would be your perpendicular slope? Negative 3 over 4. Excellent. All right. Now, here's a tricky one. If I said 2, what's the perpendicular slope? Negative 1 over 2. So that's where students sometimes they mess up is when they have the whole numbers and integers. Okay. So what we're going to do is we are going to plot, first of all, we're going to plot EK first. So we have negative 2, positive 4, right here. 4 over. Oh, good job. So we have to go negative 2 and up. 1, 2, 3, 4. Good job. You guys are paying attention right there. All right, and we have what? 2 what? 2 negative 2. 2 negative 2. So what we're going to do first is we're going to draw this line in. All right. And then we're going to figure out, it's not a very good line. All right, draw this line in, and we're going to figure out the slope of this line. Like how far does it go down and how far does it go over? So we got to figure out like how far does this sucker go down, and how far does it go over? All right. So automatically, without telling me the exact slope, what type of slope is this without telling me the exact slope? It's negative, all right, because we know it's going down. So how far does it go down? It goes down 6. So that's negative 6, and it goes over positive 4. So our slope, if I said, what's the slope of EK? The slope of EK, everybody, is negative 6 over 4. But we changed that yesterday. What did we change that to? That's right, we put in negative 3 over 2. So slope, EK, is equal to negative 3 over 2. Now, what's the perpendicular slope? If you apply this concept, what's the perpendicular slope of a negative 3 over 2? 2 over 3. This right here is the slope. This is the new slope. So if it asks you to graph something that's perpendicular, make sure you find not just the old slope, but you find the new slope. So we're going to take this 2/3 and we're going to apply it. But what point are we going to apply it to? Somebody said Z. Right, so we got to apply it to this guy right here, which is at a -3, 0. So what are we going to do? How do we apply the slope? We go what? Yeah, give me instructions. Up 2 to the right 3. Up 2 to the right 3. And then and only then have you created a perpendicular slope. Now, if we did this correctly, everybody, if we did this correctly and things are perpendicular, what angle should this be right in here?
90.
It should be 90. All right, so we would have to check with the protractor if indeed we did it correct. Well, looks like I didn't draw it perfect. All right, but you'll notice that it does fit right in that corner right there. Okay. So I'm not going to erase the line, but we did make a 90 degree. All right. So that's what we did yesterday. We had to be able to find slope and be able to graph lines. Today we're going to be building equations. Okay.